Now, this calcium oxide water, if you pour water, how will you identify difference between this and this? Is it possible for us to identify? Sorry?
Heat and
Now, just calcium oxide, you can see calcium oxide is there. It's just a solid substance. Solution of calcium oxide, we are calling it as calcium hydroxide. Simple. Common names we know. What is this common name of calcium oxide? Quicklime. When you add water, then it will become slate-like. So whether just by passing carbon dioxide, we also cross-check whether it has converted into slate-lime or not. Because into slate-lime, when you pass carbon dioxide, it converts into calcium carbonate. It turns transparent liquid into milk. Right? Okay, let us try to conduct the same experiment. We'll be taking a small quantity of quicklime and so quicklime is just like a face powder, right? Lot of salts usually. There'll be, salts you can easily identify. Salts also have two types. Whenever you come to lab, you can observe. This is actually fine powder. We call salts actually crystalline salts and amorphous. We call it something called amorphous. If you take amorphous, they are quite fine. Face powder, if you take face powder and press it, do you feel that trickiness? No. But if you take salt and press it,
yes.
Right? There are two different types of salts. Now this calcium oxide, it is just like your face powder, quite fine, okay, clear. So just try and add little water. Now, how to identify whether the reaction is happening or not? Have you learned something called evidences?
Yes.
Evidences. There are 4 evidences, right, in your textbook, which will prove whether the reaction is happening or not. Which are the 4 evidences?
Change in color, change in state, evolution of gas.
Change in color, change in physical state, evolution of gas, change in temperature, right? Fine. Now, here, I think in the reaction already ma'am has mentioned that heat will release when we do this combination reaction. If I take calcium oxide in large quantity and add a little water, I can't see the heat is evolving, but at least the test tube will become slightly hot. Okay? So by that, you can conclude that combination reaction is happening. You get what I'm trying to tell? So conclusion based on whether the test tube is becoming hot or not, we can able to conclude the reaction is happening or not. Okay, fine. Let me, Metal oxides, basically we call them as, what do we call them as? Metal oxides?
Base.
Neutralization reaction you have learned somewhere?
Yes.
Okay. Now, calcium hydroxide, any base actually, calcium hydroxide will react with any acid. What will be the product?
Salt and water.
Okay, calcium hydroxide. If I react with HCl, tell me the product quickly. Is this neutralization reaction?
Yes.
Now, in this place of CaOH twice, if I take calcium oxide also, I'll get the same product.
Yes.
Yes.
Right?
Yes.
Now, this one, in place of base, I am using metal oxide, yet I am getting salt and water. So metal oxides, we can conclude that
Bases.
right? Now bases, what do they do with litmus paper?
Blue.
No?
Blue.
Are you sure?
Yes.
Okay, we'll just check whether it is a base or not.
Yes.
It is? It is, right?
Yes.
So it just turned red litmus blue. If you want, you can dip the same again blue color litmus paper into some acidic solution. Again, it will turn back into red color. Right? This is a small test. Now, if I add a little more water to get a transparent liquid, I'll add a little more water and just try to dilute it more. And the respiration, I think, biology experiment happened?
No.
Biology experiment?
No.
Where exhaled gas contains what? Carbon dioxide, right? Okay. Okay. So if you consider little, actually I have taken more calcium oxide. If you take a little less quantity, you can see a translucent kind of liquid. It's not completely transparent. Translucent kind of liquid can be seen. But when we blow the air, what do we exhale? Carbon dioxide. Slowly, it has to turn into what? So actually, this. What is this? This is different. Fine. Slowly, actually, calcium oxide is settling down. The insoluble calcium oxide is settling down. The upper portion, whatever is there, no, that solution you need to take. That is obviously calcium hydroxide. When you blow, it has to turn into calcium carbonate. I think when we were revising, I told you one more point actually. When I blow more carbon dioxide, excess carbon dioxide, this calcium carbonate turns into calcium bicarbonate, and calcium bicarbonate is soluble in water, so the milky will disappear. Right? Okay, just we'll try to blow slowly. If you blow, it may just come out of the test tube. For color comparison, in fact, we want just try to put it into some other test tube and remove it. Any changes are happening in that?
Yes.
And try to observe the color, whether it is becoming milky or not. Just try to observe the color. See the difference? I have taken the same solution. Is there difference in this or not?
Yes.
It has turned milky, right? If I continue to blow, that milky nature will also disappear, right? So this experiment proves that this is slate line. I have blown carbon dioxide, has turned into calcium carbonate, right? In the same condition, without disturbing, if I filter, I can extract calcium carbonate separately and liquid can be separated. In that way also we can. Fine. Exchange of ions will take place to give two new products, right? Okay. Now see the reaction here. What are those salts we are going to take?
Sodium sulfate.
Okay, perfect. Now I will prepare sodium sulfate and barium chloride solution in two different beakers, and that solution I will give you in two different test tubes. Each three groups, whatever I told you, no? I will be giving you two test tubes. In one test tube you will be having sodium sulfate, another test tube you will be having what? Barium chloride. Now, both will be usually transparent liquids. Those transparent liquids, when you add, what will happen, that's what you need to observe. Right? Wait for a minute so that I'll just prepare the solution and I'll give it to you.
Sir, we use distilled water, right? We use
Yes.
will there be slight variation?
If we use distilled water, then
No,
usually
we are using distilled water. If we use this tap water,
the tap water obviously it contains dissolved salts, right? Those salts basically they don't give common products for it. In your manual, they might have given proper procedure also, like how much of quantity you need to take salt and as well as water. But we are just trying to, sir, there are two types of analysis. One is qualitative, another is quantitative. Qualitative, you can take quantity how much ever you want. Just you need to see whether the product will come or not. But when we talk about quantitative, you're going to identify how much of, for example, how much of barium sulfate you have to produce based on that quantity. When we talk about quantity, we will take accurate measurements of these two reactants. But this is what kind of analysis we are doing. Qualitative or quantitative?
Qualitative.
Okay. We need to just check whether the salt obtaining is different or not. Fine. We are just trying to make a salt solution. This is sodium sulfate. There, we can take a glass. Can I use the same glass to prepare this solution?
No.
What will happen?
They both
They
will
reacts.
Yeah. They react and the product, before you try to mix them, the product would have become something else. Okay. So one person from each group just come and collect sodium sulfate. Okay. Sodium sulfate we have given. What is the nature of sodium sulfate? Is it a solution or semi-solid? How is it? Just check the first. Is it a clear solution? Aqueous solution? Okay. Almost clear solution, right? Next, we have one more clear solution. Which is this? Barium chloride. Barium chloride. Until and unless I tell you, you should not mix this group. Hold the barium chloride. Next. Okay. Who's the making noise?
Just show both.
It is just solution, boys. Don't do anything with that. Just hold the test tube in your hand. Can't even make out which is sodium sulfate, which is barium chloride. Right? Now, first you observe the result, what I am trying to do. Anyways, I have excess of salt solution. I try to mix it. In double displacement also, we have two types of double displacement. One is precipitate, another one is neutralization. So under double displacement, whatever example I wrote that time, that is double displacement neutralization reaction. That means what about this reaction? Now what is precipitate? Insoluble or semi-solid substance will produce. Now I have both transparent liquids, but I am going to get a insoluble substance. White precipitate is possible, right? Let us try to add these two and see the color change. All of you can see this?
Yes.
Right? Okay. Anything I can add, I'll just try to add drop by drop. See the color change. Formation of precipitate, can you see white color precipitate?
Yes.
Right? Complete transparent liquid is converting into something. Can you tell me the product? What is the white color precipitate? Is it barium chloride or barium sulfate? Barium sulfate. Okay. So you can see the color change. Transparent liquid has completely converted into white color solution. Right? If I allow this liquid to settle down, who is that? Who is that?
Aren't all double displacement reactions precipitate reactions?
Yes. That's what. But we have neutralization also. There you won't get precipitate, right?
No, all of them are precipitate reactions because
Yes. Precipitate will form in all double displacement reactions. But if you take neutralization, you won't get any precipitate. Only salt and water. Right? Okay. Now it is your turn, boys and girls. Both the test tube solution. Try to mix slowly. Don't pour completely. Drop by drop you pour and then observe the color change.